Kendall has worked for TCEQ since 2018 as an environmental investigator. Her duties include conducting comprehensive compliance investigations and other on-demand investigations at public water systems. Please welcome Kendall Katara.
So like Jackie said, I'm Kendall Katara. I'm out of the same region as Crystal. She's actually my boss. And I'll be talking about how to prepare for a surface water investigation. This presentation is going to look kind of similar to Crystal's, but I am going to try and focus more specifically on like what's different about a surface water investigation versus groundwater. We're kind of going to go over why are you having an investigation, and more specifically what to do before and what's going to happen during the investigation, and then we can go over some helpful resources. Why the compliance investigation? Because the EPA said so. If you're from other states, they'll call these inspections a sanitary survey. We call it a comprehensive compliance investigation, or CCI. And so for community systems, we do that once every 3 years. And then if you're a non-community system, you do that once every 5 years. Most surface water plants tend to be community systems, but every now and then we'll have like a state park or a camp that runs off a surface water plant. So they get thrown in there once every 5 years. So what to expect before your CCI, we'll give you a call and try and schedule a date for about 2 weeks out. And then we'll send you a confirmation email letting you know, confirming the date and time we agreed at, where we're gonna meet. We're going to give you a list of documentation that we'll want to look at. When I'm sending my confirmation email for surface water investigations, I'll let you know extra information, like I'll want to see one of your filters backwash if you have conventional filters. So, that way you'll know to kind of hold one for the day so I can watch that backwash. Any extra information about your plant that's specific to it, I'll include that there. Like if I can go and see your raw water facilities. I know sometimes you don't necessarily own your intake, so if it's too difficult to try and get out there, we can work something else out for that. And then depending on the region, we may request documentation ahead of time. Specifically, some people will ask for like the last year of your SWMORs to be submitted ahead of time, so that way we can review that and take up a little less of your time the day of. So how can you prepare for the inspection? You're gonna wanna gather all those records in that list that I'm gonna send you. Contact any individuals that may have records. So I know surface water systems tend to serve larger populations, so a lot of the times you'll have plant guys versus your distribution staff, versus if you're at a city, you may have like a code enforcement that does the backflows or the customer service inspections. So that 2-week window is really for you to try and get everybody coordinated, get all the information off that list, and coordinate with staff schedules, make sure that we'll have somebody who can take us out to your distribution facilities and monitor out in distribution, as well as give us a tour of the plant. Inspecting your facilities ahead of time is really helpful. Just doing a walkthrough of your plant and any of your distribution facilities. Don't wait for me to come out there and see that the weirs at your sedimentation basin are clogged with algae. Kind of clean that up before I get out there. And just any other preventative maintenance that y'all might think is necessary. So what to expect during the CCI? We'll arrive there, we'll have a general entrance meeting, just letting you know, like, okay, let's look at paperwork first, or, if it's gonna be a hot day, maybe try and get out and look at the plant first. And then we'll review all those records that we sent you before, as well as an evaluation of the surface water plant. I like to walk the flow of the plant, so I'll ask you to take me to where water enters your plant, and we'll literally walk the flow of water throughout it. So every chemical injection point, the different treatment processes that y'all go through, I'll wanna see all of it. Watching a filter backwash is really crucial to me. I like seeing how that operates. I like to see how operators understand doing a backwash procedure. And then once we're done looking at the plant, then we'll go out into the distribution system. If y'all have any additional pump stations or elevated storage tanks, we'll go look at that. And then I'll take a disinfectant residual and a pressure in each of your pressure planes that you may have. And then there'll be an exit interview meeting. If not, we'll also give an exit interview form at that time. It just kind of depends what information we need to go back over and confirm before we give the exit interview form. So the entrance meeting, once again, we're just gonna outline what's gonna go on there. We're going to confirm if we need any PPEs. I know some of the larger plants are always under construction, always updating something, upgrading, doing some repairs. So do we need hard hats? Do we need the bright fluorescent vests? That sort of a thing. And then identifying all the individuals who are there, letting me know, like, you know, this is from code enforcement, and who is the distribution team, who is the surface water team. So that way I can understand who I need to be directing questions to. This is the list of all the records that we'll be taking a look at. For surface water systems, there are a couple of extra documents that we'll be looking at, specifically CT studies, SWMORs. There's a lot more equipment to keep track of at a surface water plant, and with that comes a lot more of calibration and verification records. And then operator requirements, there tend to be a little specialization of different requirements for operators. One of the new rule changes is for the plant operations manual. Surface water systems tend to already have a pretty flushed out plant operations manual, but for here, just keeping with the theme of weatherization and ensuring you can keep your plant operational in all conditions, identifying that critical equipment with relevant vendors. So say from the west side of the Metroplex is where you normally get your chemicals from, that's all iced over. Maybe know a guy out in East Texas that can bring it your way if it's not frozen over there. That kind of information is key to making sure you can continue operating. Knowing your local water systems is also good for being able to share equipment or chemicals in a time of need. But yes, any other key SOPs, key personnel, that information's good to know. In the spirit of new rules, this is also a new rule, so generators, operating those under loads and the different variations of it. Within the new 290-46-8 rule, we have it very flushed out of all the little specifics that are needed there, so I would definitely recommend going and taking a deep look at these new rules. More than just this 30% load once a month, but. And so like I said, operators for surface water systems, there's gonna be more specific kind of requirements for that. Serving no more than 1,000 connections, you'll need at least one operator who holds a Class B or higher. A part-time operator can be used to meet this requirement if they are completely familiar with the design of the plant and spends at least 4 consecutive hours at the plant once every 14 days. And you'll also have a C operator on site. What's key about that rule is making sure that if y'all are having that contract B operator, he needs to be keeping a log of everything that he does when he does go at the plant, so we can ensure he is actually spending the adequate amount of time there for y'all. And then effective in 2007, the water systems must use at least one operator who's completed both the Surface 1 and Surface Water 2 production courses. If y'all serve more than 1,000 connections, you'll have to have at least 2 operators, one who holds a Class B and one who holds a Class C at least. Each required operator must work at least 32 hours per month at the PWS, either in the production, treatment, or distribution facilities. And once again, they're gonna have to have taken the production 1 and 2. Some other specific needs, if you're using chlorine dioxide, you always need to be under the direct supervision of at least a Class C or higher surface water license. RO and nano filtration membrane systems. Y'all are gonna have to have operators that have successfully completed at least one of the director-approved training courses specific to operations and maintenance of RO membrane treatment. That's something that's really important for ensuring your operators understand the equipment that they're using and also understand just its limitations and its upkeep that's needed, because those are really expensive to potentially mess up or foul. So just ensuring that they have the correct training and that they can adequately operate the machinery is useful for y'all. Each surface water treatment plant must have at least one Class C or higher surface water operator on duty at the plant when in operation, or the plant must be provided with continuous turbidity and disinfectant residual monitors with automatic plant shutdown and alarms to summon operators to ensure that the water produced continues to meet drinking water standards when not staffed. So the key part of that is if you're not gonna have somebody at the plant all the time, but the plant may run when somebody's not there. Like I know a lot of packaged plants can kind of turn themselves on and off even when you're not there. You really need to have that online continuous equipment that will also work with your SCADA to shut the plant off or go to filter to waste when a trigger is met. That's the way to ensure that, you know, while nobody's there, you're also not gonna be sending any water that's not meeting drinking water standards out to your customers. The other piece of information that's really important for your surface water system is your CT study. It's essentially another version of like a monitoring plan for your plant. It's showing us how you're going to provide clean and safe drinking water, how you're going to meet your log inactivation for crypto and viral loads, how you're going to effectively reduce turbidity throughout your plant. It's a really important document for everyone to understand. And then, like I said, hand in hand with your CT study is your SWMOR, because that's essentially a reflection of how your CT study is put into place and how it is working throughout your plant. Ensure that you have those last 12 months of SWMORs available, because you can really see differences throughout the different seasons in your SWMOR of how your plant will be able to operate. I know membranes tend to not really love the winter time because they don't like cold water as much, you know, and conventional plants do great in summer months. So it's just, you'll kind of learn a lot more about your plant the more that you get involved with understanding your SWMORs and how the data gets input into there. Ensure that operator bench sheets that are used to fill out the SWMORs are also available as well. So a lot of the times I like to compare what y'all have input on your SWMOR to what your operators are putting on their daily bench sheets when they're running all these daily, hourly tests that they do, just so it can ensure we all know where the data is coming from and where it should be coming from. And just ensure that you're using the correct version for your surface water plant. They have a new form out there right now called the SWMOR Combined, and that's pretty much a catch-all for everyone that you can customize it to your plant. We used to have like a bunch of varieties of the SWMOR. This was created to kind of condense them all into one. So hopefully we can all avoid using incorrect versions of it. Like I said, at a surface water plant, there's a lot more equipment that goes into that treatment process, which also means there are a lot more calibrations and verifications that need to be conducted on a variety of different timelines. Key difference here are your flow meters. So there are typically about 4 different types of flow meters at a plant. There can be a lot more, especially when it comes to process control duties, you know, just helpful information. But these flow measuring devices need to be calibrated at least once every 12 months. Typically, we'll see a raw water meter, a backwash meter, reclaim, recycle meter if you're returning your wastewater to the front of the plant, and the finished water, so what you're sending out to distribution. You can have many different flow meters. You can have several different backwash meters if you have different trains that feed to filters. if you have a conventional filter train versus like a membrane filter train. There can be a variety of meters that you use. Some people use flow meters to monitor the flow like through their sed basins. Lots of different ways you can run a plant, but these need to be calibrated once every 12 months. pH meters, bench tops need to be calibrated at least once per day. And then you need to verify against at least one buffer each time a series of samples are run. So say you calibrate it for the day, run your pH sample that morning, and then that afternoon you're gonna run another sample. You need to verify the pH probe against like a 7 buffer before you run your sample. Make sure that the pH probe is still within calibration. They can be a little finicky, so you really just wanna make sure that it's still reading within a good range. Online continuous pH meters need to be calibrated to the manufacturer specs at least once every 30 days, and then verified once each week with a primary standard or compared against a calibrated benchtop. Turbidimeters, the benchtops need to be calibrated with primary standards at least once every 90 days, so essentially once a quarter. Secondary standards shall then be restandardized. Check the secondary standards each time a series of samples are run. So once again, like with your benchtop pH meter, here turbidimeters can also be very finicky. So each time you run samples through that turbidimeter, verify it with 1 or 2 of your secondary standards to make sure that it's still reading within a good range. Online continuous, those also need to be calibrated with primary standard once every 90 days. And then you need to check it once per week with either a primary or secondary standard or compared against a calibrated benchtop method. Disinfectant residual analyzers, the manual analyzers, so like a DR900 or a DR300, those need to be verified at least once every 90 days with chlorine solutions of known concentrations. Also, a lot of surface water plants will use a total chlorine residual, so you also need to make sure that what you're using to verify how well you are getting a total residual versus a monoresidual, you'll need to verify the accuracy of that as well. Online continuous disinfectant residual analyzers need to be checked at least once every 7 days with a chlorine solution of a known concentration or compare it against a benchtop method. For the chlorine analyzers, the online ones, once it does not read within the, or it doesn't compare against your benchtop or it doesn't compare against the concentration well, that's when you'll need to do a full like recalibration of the continuous reader. So now that we've kind of gotten through all the paperwork side of it, what to expect during your CCI, like I said, I like to walk the flow of the plant. If we can start at the intake or raw water pump station, that's a good place to start. If not, then we're gonna start where water enters your plant and any chemical injection points in between, going and looking at your rapid mix, flocculation, clarification, sedimentation, filtration. I'll wanna look at all your chemical storage facilities, the finished water storage, and I'll also wanna look at your waste management. So at the raw water intake or your pump station, we're gonna make sure that the intake is protected against potential contaminants, AKA there aren't any boat ramps or marinas around within like 1,000 feet. Make sure that y'all are trying to advertise a 200-foot restricted zone around your intake, intake screens to minimize debris, all-weather road to your raw water intake, and then that there's a lockable building or intruder-resistant fencing around your raw water intake facilities. Like you can see out there, a lot of the times the intake's out on like a nice pier, so it can be relatively easily locked from intruders. Another point for raw water intake is we want to make sure that your facilities can remain operational during flooding. So if, say, your intake's on a river, you want to make sure that, you know, if the dam upstream releases some excess water that they may have gotten during a big rain event, that's not going to flood out your river intake. We'll look at rapid mix. which is at least one hydraulic mixing unit or 2 parallel mechanical mixers. If you produce more than 3 MGD, here are pictures of different versions of rapid mix that you can see. Sometimes it's just as simple as having an inline static mixer. Flocculation, so parallel flocculators or supplemental sources for plants that are greater than 3 MGD. Flow from flocculators to said basins. We want to see that it's preventing the destruction of your flock. So we'll want to see like counteractive movements with your flocculators and ensuring that you're actually creating a good and stable flock. Clarification and sedimentation. So once again, parallel units at a surface water plant, you'll really want to have duality in a lot of your processes to ensure that you can always be providing water out to your customers. The length of a straight flow said basin needs to be at least twice as long as it is wide. Unless you have plate settlers at the end of it, you'll have to get an exception for that kind of detention time within the said basin, but that's something we're seeing a lot more common now. And then we'll want to make sure that your clarification and sedimentation basins are being maintained well for sludge removal. You know, you're not letting it go anoxic. It's not building up its sludge at the bottom. Y'all can effectively remove excessive buildup. Filtration, we'll want to check the visual condition of the media, make sure that it's acceptable. I'm not seeing any pitting or mud balls or like a lot of excessive chemical carryover from the sedimentation basins. We'll want to make sure that y'all are equipped with sample taps and that the filters have rate of flow controllers, especially for during backwashes. Having a rate of flow controller is really key to ensuring you're going to get a good backwash out of your filter. Another point of watching a filter backwash is I like to know what your maximum backwash rate is so I can ensure that you're getting a good consistent backwash rate for your filter so that it's getting agitated enough while you're doing your backwash. And having your filters equipped with online turbidimeters if required, and no online turbidimeters and the recorder equipped with a loss of head indicator. Most filters nowadays are going to have the online turbidimeter on it, but if you're still running a relatively older plant, you may be working off a loss of head indicator. The other part of filtration is going down into that piping gallery and ensuring that there's adequate room, light, and ventilation for the drains in the pipe gallery, proper identification, and what's really key is ensuring the filter to waste includes an air gap. So over on the side, I have a list of general color coordination that you can use for your piping throughout your plant. This also includes chemical piping. So in lieu of labeling what is there, so instead of saying like raw water on a pipe, if you use it with this like brown color, I can understand that this is a raw water pipe. Settled water tends to be a green color, and then anything filtered is gonna be a blue color. Same thing with chemicals, different patterns of colors will indicate to me what chemical is being transferred through that line. Speaking of chemicals, chemical storage. So bulk storage, do y'all have at least a 15-day supply of chemicals on site for your plant? Do y'all have day tanks to prevent overfeeding of chemicals? And the biggest one that we find at surface water plants are, do you have secondary containment for all of your liquid chemicals? And can it hold up to 110% of your typical amount of liquid chemical that you'll have there? As you can see here, there's like a variety of ways that you can achieve this. Cutting an old chemical tote in half from like a bigger chemical and then putting your smaller tank in there, that can work as long as it holds 110%. A lot of the times we'll see the little yellow boxes at a plant, or for bigger facilities, you may build in your own secondary containment with concrete enclosures. All of that's perfectly fine as long as you're not storing incompatible chemicals together. You want to make sure that you're not going to have any reactions if both happen to leak at the same time. Another part of chemical storage that I'm gonna look at is for your feed lines, do y'all have the appropriate backflow that's needed? Sometimes you'll have a giant backflow for all of your plant water. And then sometimes you'll do it more specific to the different feed structures throughout your plant. So keeping up with that is important. Those are also all gonna be either air-gapped or RPZs, and those will need to be tested annually if it is a RPZ. Finished water storage. It's gonna be very similar to any of the regular ground storage tanks. Are they equipped with the liquid level indicator? Is the overflow with a gravity hinged weighted cover? That we're gonna make sure there aren't any common walls with other plant units, and is it being properly maintained? And what's especially important at a surface water plant is that the inlet outlet is designed to prevent short circuiting. A lot of times, the water storage of your plant is your clear well, which is where you're gonna get a lot of your contact time with your CT study. So ensuring that you get good water flow through that tank is gonna be important. Waste management, so where all your backwash water goes, where your sludge from your clarifier or sed basin goes. We're gonna make sure that you have adequate sludge management. I've been out to plants where they had like a mini forest growing in the sludge lagoons. So just ensuring that you're managing the sludge, getting it dried out when it needs it so you can get the sludge hauled off. If you have reclaim basins, ensuring that you're adequately getting removal of the solids out of your waste stream so you can send better reclaimed water to the front of your plant. And then there are different versions of how you can do waste management out of your clarification. You know, you can have the circular rakes that kind of rake it into a little hole at the bottom of it, or there are the racks that can pull it all the way through. It's just kind of up to how the engineer had designed it. What can be helpful once I've gone through your plant? Maybe I've noted some problems, or maybe just some things that you may want to discuss a little further with some of our TCEQ staff. Our TCEQ website has a lot of really helpful information on it. It has guidance documents and just different resources for how you should be operating. Other helpful resources, specifically RG211 is gonna be really great for y'all to understand where the information in your SWMR, where you should be pulling that from in your plant, and what's gonna be the correct information to put there. It's gonna clarify, you know, do I put an X here for this 4-hour block period if I didn't produce any water at all, or yeah, it ran for about 15 minutes into this next block. You gotta report that then. All those little nuances to the SWMOR are gonna be explained in that regulatory guidance doc. The Water Supply Division, like I said, a few different teams. The Surface Water Treatment Rule team is really great at helping you with troubleshooting any problems you have with your SWMOR as well. And Water Supply Division also has the TOP team, the Texas Optimization Program. Not only are they optimization, but they're also troubleshooters. So if y'all are having problems at your plant with different treatment that's coming up, say you're getting a huge slug of manganese, you've never gotten that before, and you're kind of lost on how you're gonna face that at your plant, they're great at troubleshooting those kind of problems with you. TCEQ small business and local government programs. Once again, they're really great at helping you create documentation that's needed at the plant. You know, they can kind of help create your daily bench sheets. They can help ensure that your code enforcement side, maybe they weren't doing what they needed to. You can let them know about this and they can help them create a better cross-control program. So they can help with not just parts at the surface water plant, but parts for all of your water system. FMT, once again, is a really good resource as well. They can go out on site and provide free assistance to y'all. And then the regional investigators. I like to help y'all before it's a problem when I come out there. If you want to call me and give me a hypothetical situation, I will try my best to help you. And if I don't know, I probably know the person in Austin you need to talk to. So just reaching out to your regional investigators. We're here to help you. Like I said, we all want everybody to have safe and potable drinking water, so reach out to us. We are a good resource as well. But all right, any questions?
There are a few questions from the online audience. What type of generators are needed?
It depends on your plant and what's considered a critical component. That's going to so that will kind of dictate how big of a generator you need. If it's possible that you could run it with or there are other options you can use out of the EPP as well. So it's really just plant dependent.
Okay, thank you. And then one more, is backflow prevention required on your filter backwash line?
Not necessarily. Like I said, sometimes plants will have a backflow prevention at, the plant water line. So that's kind of already ensuring that, you're ensuring the safety of the water used throughout the plant, whether it's for the chemical feed line or backwash water. So as long as you're ensuring nothing can re-infiltrate into your treatment process or re-infiltrate into that clear well that has your, treated potable water, that should be good.
There is one additional question on the generator. It says, can you show the one in the slides, please?
Yes. So the part up top is like the quick connect systems that are also important to have for your generators. That just ensures if there is a loss of power, that it's going to automatically flip that generator on. So you essentially at the plant shouldn't really lose power in a sense, because you'll go straight to using your generator.
Yeah, I just wanted to say that I've seen a presentation about generators, and one of the issues that they found is that sometimes if you use diesel, they have to check the longevity of that and make sure it's not deteriorated. Mm-hmm. And so you must follow their maintenance operating procedures for the generators if you have a certain generator. So make sure that you follow their manufacturer requirements, because it could be that your fuel is going to be too old and it's not going to be useful, and it causes deterioration and degradation of the fuel whenever you get ready to use it in the case of an emergency.
Yes, and that is a good point. As I had noted, there were a lot of other rules aside from just, the monthly testing under 30% load. One of those other rules is you have to have, I believe it's like 48 hours worth of fuel on site wherever you have a generator. And so that kind of plays into you're storing this fuel on site for however long until you actually need it. So that's a good point to make sure that you're ensuring that it's actually a good, viable fuel that you have on site. Thanks, everyone.